Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we had a bit of a maintenance episode. We fixed some things up and moved some things around just to organize Hazel a little bit more. Check out that video if you haven't already. I also talked a little bit about maintenance in general and how to approach that kind of from a software engineer's perspective. Today, we're gonna have a little bit of a look at what's changed in the Hazel repository, because in the last episode, I kind of told you guys that if you want to contribute to Hazel, you can just open some pull requests, fix some warnings, fix some other things. And there's a lot of stuff that has actually happened throughout the week, which is really cool to see. So we'll kind of look through that a little bit. And the other thing that I want to do is kind of prepare Hazel for 2D rendering. So what I mean by that is we basically want to take the sandbox layer that we have at the moment and kind of, I guess, extend that, or maybe even make another layer so that we have everything we need to kind of test the 2D renderer as we start doing that. So in other words, I want to create like an isolated test in a way, like a sandbox test for the 2D renderer, so that when we actually start working on it, hopefully next week or the week after, we'll be able to just get down there a lot easier. And I'll be honest with you guys, this has been a very, very busy week for me. I almost didn't want to release an episode today, but I thought that if we just kind of look at some issues and we kind of just move some things around and set up a more kind of, I guess, a more robust test case for our 2D renderer, that will probably be a bit of a better use of that time than just skipping this week's episode entirely. First of all, I just want to thank all of the patrons that make this series possible. Patreon.com/thecherno. You guys will get access to a whole bunch of stuff if you help support the series, including the Hazel development repository, which is basically a version of the Hazel engine that I've developed in my own time that has, like, you know, animated 3D PBR rendering and just a whole bunch of stuff. You guys should be familiar with what Hazel Dev has. I do want to make a Hazel Dev video soon because I've added a few other things to that, such as multi-threading, for example. So there are some changes going on with that. But as I mentioned, super busy week. Almost got nothing done to do with this kind of stuff this week. But let's jump in and have a look at what you guys have done this week, because you've certainly been busier than I have. And then we'll go ahead and probably change up Hazel and create that new kind of layer for that 2D renderer. Okay, so this is kind of all the commit history that's happened. So I kind of did this upgrade to Visual Studio 2019 with organization, and this is everything that we did in the last episode over here a week ago, as you can see. And then today, this is kind of all the stuff that's happened since then. So all of it was kind of committed 4 days ago. Lovely Santa, who is one of the kind of core Hazel engineers, I'll call him. He's a really cool guy who's been doing a lot of the kind of moderation and also other small tasks around Hazel, which is really cool. For example, he actually wrote this contributing to Hazel document, which is really cool to see. This is what you guys should read if you want to contribute to Hazel. There's a lot of stuff here, which is all really, really good. So definitely take a look at that if you're interested in actually contributing. The contributions in general, I don't want to talk about them too much. I might make a video dedicated about that. But contributions in general are very tricky with Hazel, because obviously this being an engine that I'm trying to write by myself to show you guys how to write an engine, if there's too much work that goes in from your side, then that makes it more difficult for me to actually show how to build an engine, if you know what I mean. So for example, if someone wrote a 2D renderer and they were like, here, you know, this is a 2D renderer, here's a pull request, accept it. If I do that, I can't just be like, so by the way, someone added a 2D renderer, blah, 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 because a lot of you want to actually see how to write a 2D renderer, how to integrate that into Hazel, how that gets done kind of from scratch. So because of that, it's really tricky with this. I've mostly limited this to just be like fixes and minor like changes. For example, you know, there are obviously little bugs that I've written, other things that you'll see here that we'll go through this list that could have been changed or could have been done slightly better. Stuff like that is exactly what pull requests are for. For example, fixing compiler warnings, right? Which I know is not the most satisfying thing to work on for you guys, which is why feel free to fork Hazel and do whatever you want with it, right? Write a 2D renderer, write a 3D renderer. Do whatever you want, and then you can share it hopefully on Discord with the rest of the community. The Cherno.com/Discord, by the way, I'll have a link in the description to that Discord. But feel free to do stuff like that. And then obviously if one of you guys does write like a full-on like 2D renderer or 3D renderer, or you do something cool, I'd love to kind of showcase that in a video. I've got no issues with that. It's just that when it comes to this kind of Hazel repository, the master branch and all of that stuff, I do kind of want to keep that as something that we actually work on throughout these videos. I have thought a lot about the future of Hazel because these videos are getting harder and harder to make. Because, you know, especially when it comes down to designing and implementing a 3D renderer, 2D is not so bad, but a 3D renderer or like a UI system or like a post-processing system, those are all really quite large systems. And for me to sit here and type out all the code in front of you, like this is the kind of stuff that would take an engineer a week of full-time work to do at like a game studio or out of like a software company, right? This isn't something that I can condense into like a less than 40-minute video, for example. So I think that even though I love the live coding in front of you guys, fortunately, I think at some point we are going to have to go back to just looking at diffs and kind of explaining how this works. I might try and do more on the OpenGL series side of things, where maybe like we'll write an OpenGL base library, and then on that we can be like, I can be like, this is how you write a fast 2D batch renderer in OpenGL. Right? And then you guys can kind of, and that'll be like kind of an in-depth video potentially, that will probably describe a lot of the theory and then kind of go through the implementation. And that might be more of like a learning exercise, whereas this inevitably, unfortunately, is going to turn into a project where instead of writing everything line by line, it's just going to be like, so this is what we did this week, this is what we did this week, which I don't know. I don't know what to do. Like, to be honest, if you guys want to help me out in the comments, I'm all ears, because, you know, writing a game engine line by line in front of someone, especially if you don't have the bandwidth to kind of do that every day, in the form of live streams, for example, which I just can't do. It's a tricky one. But anyway, let's not talk about that now. Let's look at what you guys have done in the past week, and then we'll kind of talk about refactoring Hazel as well if we get the chance to. Okay, so these are all the commits, as I mentioned before. Let's take a look at these. So stuff like, well, the ones that I wanted to actually take more of a look at, because you guys can take a look at this yourself. If you just go to the Hazel repository and then click on the commits, you'll see all the commits, and you can actually view the diffs by just opening up the commit hash over here, and then you can see how that works. So this is a good one, for example. Automated platform detection using predefined macros. So in other words, compilers predefined macros based on the platform or compiler that's being used. So for example, underscore Win32 is defined when you're using MSVC on Windows and your configuration is set to Win32. Well, same with Win64, so that's actually true for both architectures, but this one's obviously only true for x64. If that's not defined, we can assume that we're trying to do an x86 build, which isn't supported, so we can just output an error there into the compiler so that we actually don't compile and output that in our output. You know, for Apple, kind of the same thing here, and also for Linux. So that's kind of the idea with doing this. This is the kind of stuff that I like to see in contributions, because this isn't like a major system we're writing. These are just a series of macros to make everything a bit smoother in terms of compilation, and just making sure that we're not accidentally not defining the right macros. Just makes everything a little bit easier, but doesn't really change massive systems, which is something that we don't want to really do off camera. The other one that I kind of liked was this check for an OpenGL version. This is something really, really basic, but this just basically asserts that we are using OpenGL 4.5, and if we're not, it's going to assert. Whether or not this is required, again, is questionable, because you might just, you know, it's just, ultimately you might just let the engine crash if it's not supported, but that's obviously not a good thing to do, because in that case, people might not know why their copy of the engine is crashing, or why what they're trying to run is crashing. Whereas here it's just going to tell you that it's because your OpenGL version is incorrect. And that happens inside OpenGL context, which of course is important, because we only want to do this kind of thing if we're actually using OpenGL. So there's a bunch of stuff here that you guys should check out. There's also a fix for the orthographic camera's movement. This is something that I didn't even look through this. I'm not sure I agree with this, to be honest, but it is a community contribution. I'll take a little bit more of a look here, because what this is doing is, well, it's essentially bypassing the rotation matrix here by just calculating everything manually using sine and cosine, which probably isn't the best thing to do, but nevertheless, it does of course work. And in the future, if we need to actually refine the orthographic camera, we can address that later. So this project is also all about kind of having a community contribution, having a community develop things. Me as like the quote unquote technical director of this project, I might be inclined to do things differently, right? But obviously I can't let my team, which is all of you guys, just completely, I can't just be like, sorry guys, I just don't like your code because it's different than what I would have done. Unless there's a serious issue with it, obviously I should be here to kind of give technical guidance as well as potentially steer this engine into where it's supposed to go. But as far as contributions like this go, I kind of leave that up to you guys. If, for example, no one agrees with this person, that's why we have a pull requests tab with a bunch of comments that people can write. Feel free to go to a closed pull request in which something like this happened, right? For example, here's the one for orthographic camera controller movement. And then if you don't like this, for example, just simply write a comment being like, I don't like this. And make sure you spell like correctly. So just do something like this, discuss it. Doesn't matter if it's closed. You can still write a comment and we can still kind of talk about this stuff. Because obviously I do want this to kind of be something that you guys talk about. And then guess what, right? If there's 10 of you talking about something, you will probably achieve more than if just one person just writes an engine by themselves. So this stuff is super important. And it was kind of my hope with Hazel to do kind of more of like a community-based project, which is exactly what this is. Okay, cool. So that's enough looking at what you guys have done. Let's kind of dive into Hazel and then create that kind of 2D rendering layer, which is what we want to have so that when we actually start implementing that 2D renderer, we can test everything appropriately. Okay, so just to take a little bit of a look at what it is we're going to be doing, what we have here, if we just launch the engine, is this kind of example layer inside the sandbox app.cpp file. If we launch it, we'll see this, which is great. This was kind of the, I guess, layer that we were talking about. This is like where we've been testing everything. This is the only layer that the engine has at the moment. Which is fine, obviously, and we have kind of everything in one file here. We have sandbox with our example layer, but as you can see, this stuff was written to test a whole bunch of things. For example, we're creating vertex buffers, index buffers, vertex arrays, where we've written shaders here. This is all stuff that we don't actually want to have when we're testing the 2D renderer. Why? Because the 2D renderer is going to be really simple, right? All it's going to do is basically, like, we're going to tell it that we want to start rendering. We kind of discussed this in the how to build a 2D renderer episode, which I'll link in the top right corner. But anyway, we basically just want to be like, hey, like renderer, we're about to start rendering stuff. Here is a triangle, or here's a quad that we want to render, for example, of this color, or here's a bunch of them, and then that's it. And then we finish rendering, and we kind of tell the renderer that we're done and we'd like to see this on the screen. That's the extent of this, right? It should ultimately be, aside from the camera controller, which we'll still have, this stuff, render command set clear color, begin scene. Begin scene is something that we will have, but everything else pretty much will not be here, right? None of this kind of setting uniforms, none of this, binding textures, none of these creating shaders. We shouldn't have anything like that whatsoever. But I don't want to remove this code, because if I remove this code, then we're not going to be able to test a lot of the engine very effectively, which obviously we still need to continue doing. So this kind of example layer still is part of everything. Like, I don't want to get rid of that completely, but what I do want to do is basically create a new layer, which is going to be our kind of, we'll call it like our 2D sandbox layer, right? So I'll just make a new file, I'll call it sandbox 2D. And then what this will be is kind of the 2D layer that we need. Okay, so now that we've got both the CPP file and the header file, I'll just include the header file in the CPP file. If I go back to the header file, we'll just type in class sandbox, sandbox 2D, and then we'll have basically everything that we need inside here. So our goal for today is basically just to make this work. So if we look at Sandbox app, it's got example layer, which is great. I'll keep it in here for now. We'll do push layer, new Sandbox 2D, like that. And then we will, of course, include that. So Sandbox 2D. Okay, cool. So now we have that here. Ultimately, we don't need to push the example layer at all. We could have both layers displaying simultaneously. That's totally fine as well. But for this, we just don't want to see everything that example layer has at the moment. We'll still keep it here, but we're not going to see anything at all. Okay, so going back to that Sandbox 2D layer, what we definitely want is to have a, we need to extend layer here. It needs to be a subclass of layer. And then we'll include hazel.h, which is important. I'll just, This, of course, needs to be a Hazel layer. And the best way to do this is to kind of look at what example layer is and just basically steal stuff from there. So what do we need? It's a little bit difficult here because we do have the implementation along with the definition, or the declaration rather, but we definitely want on update. We definitely want on IMGUI render, that's going to be important. And then on event is probably something that we'll need as well. And then finally, usually what happens is during a layer attachment is when we do everything. In this case, we're doing everything in the constructor, which is also fine. But what I want to do is actually, if we look at layer, we have an onAttach function and an onDetach function. It looks like Visual Studio just got a null reference exception, but hopefully that wasn't anything critical. Well, my syntax highlighting's gone. Okay, well, Visual Studio just had fun with itself there. It doesn't matter. We'll have these functions as well, which is just going to be overrides. So this is where we'll do all of the initialization. So the constructor's not actually going to do anything. We'll do everything upon attaching and detaching the layer. This is kind of like our constructor and destructor, but the benefit is that the layer stack kind of has control over that. If we detach a layer, we can free all the resources. If we reattach it, we don't need to recreate the layer, but we can just attach it again, and that will construct everything, just in case we want to reuse layers or do anything like that, which is pretty cool. Okay, so now that we've got that, if I just go over to my CPP file, what we'll do is basically implement this, and I was gonna let Visual Assist do that, but it doesn't look like I've even got Visual Assist installed. I think everything is just falling apart here, which is totally fine. We're going to continue this episode as if everything is great, because this is the kind of stuff that happens when you're developing software. Sometimes things don't work, and whilst I probably would take the time to fix it if I was actually working on stuff not in front of you guys, since this is a video and it would be slightly awkward for me to just start messing around with trying to restart Visual Studio and doing other stuff, I'm just going to pretend that everything is great and just continue on here like this. Okay, cool. So one more virtual, and then by the time I finish my little monologue, you can see that we're done, which is great. So back in Sandbox app, what is it that we actually need? Well, again, what I would like to have is something super basic. We have a camera controller, we have a shader library, we have all of this stuff in this class, which is not something that we generally need to have for our new test layer. I would like to render at least something on the screen just to test that the layer is working successfully. So what I'll do is maybe I could even just do a clear color or something like this, but I probably will draw something. We'll have our orthographic camera controller because I think that's important. We won't use the shader library. We'll just have a single shader here, which I will read in from a file, I think, because we should have, we have our basic texture shader here, which is great. So we'll have a shader, we'll have, I guess we'll have a texture as well. So I'll steal this and I'll put this into Sandbox 2D. What else do we need here? Square color. Okay, we'll have square color as something that we can control in IMGUI, just so that we have something that we can control inside IMGUI. And then, vertex array. Unfortunately, we're going to need this stuff to render at the moment. I don't want to pull over too much stuff, as I mentioned before, because this stuff is kind of all temporary. I'll just kind of make a note here that temp for all of this stuff, because this is stuff that would exist within a 2D renderer. And in fact, by doing things this way, we also see what it is we need to basically abstract away and have inside that 2D renderer. So this stuff actually makes building a 2D renderer a lot easier. Okay, so I'll start dragging over some other things as well. So for example, on event should call mCamera controller on event. With IMGUI and settings, we can bring over that square color as well, and we'll have to sort out the includes here in a minute. Well, we don't actually need a texture if we're doing square color, do we? You know what? I'm going to ditch the texture. Let's go back to Sandbox and just get rid of that texture. We do have a texture shader, but we can probably change that around in a minute. Let's see. This is also a really good demonstration, I guess, of actually what we need to do to make a little project or a little app in Hazel. So this is going to kind of give you an idea of how I would write something like that as well. So yeah, unfortunately, we're going to have to grab a bunch of this stuff. It might be easier to just grab everything. We definitely don't need the shaders though. To grab like everything, and then, well, I'll just grab everything. I'll grab everything and then I'll start deleting stuff instead. So this goes into onAttach. Let's take a look here. Vertex array.reset. This stuff should be, I don't know why this stuff is still a pointer. These should be refs. In fact, why are they like that? So shaders are like that. I guess we just haven't done that yet. which is strange. I hope that this wasn't something that was reversed through a pull request. I'll quickly make vertex array a ref like that. So this will return std make shared with that type like that. And then if we go back to the h file, the header file, we will also make this, where's the create function? A ref, just like that. So now if we go back to sandbox app, we'll have to change this to be like that. And then in our sandbox 2D, which is over here, we'll also change that. So we're making a vertex array. We've made a bunch of vertices. This does not need to be so complicated. Are we setting, like, we're setting colors here. This must be for that triangle. Okay, cool. So I'll probably make, where's that square? So we have square vertices. This is probably what we want, to be honest. So maybe what I'll do is just delete all of this and focus on the square vertex array. So m square va, which is going to have our square vertices. We'll get rid of the texture coordinates because we don't really need them. And then we have our square vertex buffer with position and texture coordinate. We'll just have position. We'll keep it nice and simple. For this example, square indices we'll keep, of course. And then the shaders we will delete. I do want to probably move them to a file though. So I'll probably make a new shader here. And I will just call this a flat color shader dot glsl, or just flat color dot glsl. I'll exclude it from the project so Visual Studio doesn't try to compile it or anything. And then if we pop back into Sandbox 2D, I think pretty much what I want, honestly, I'm just gonna copy the texture shader. Call this a flat color shader. Get rid of everything I don't want, which is most things. Okay, so we do want the view projection and transform because we want the camera to be able to move, but we don't need texture coordinates. That looks good to me. And then output color, no texture coordinates. We'll have U color instead, which will be our a uniform vec4. And then we'll just set this like that. Okay, so that should be okay. We'll support like alpha and transparency here as well, I guess. That looks loosely good to me for a shader written in like 2 seconds. So now we'll delete everything. We'll just keep the flat color shader, which is, we actually had that. Oh, cool, we did have it, except I used a vec3 instead of a vec4 here. See the difference. We'll delete all this stuff. We'll have our flat color shader, which will just be, in this case, I think we can just create it from a file path. Is that correct? Yep. So assets, shaders, and then flat color.glsl. We won't do the shader library or any of the texture stuff at all. Cool, and then what I'll do is rename this shader to be the flat color shader, just so that we're a little bit more clear here. And then I'm GUI, something that we need. So I'll copy and paste that. Flat color shader still seems to be a little bit sad here. Don't know why that is. And Visual Studio's not telling me. Okay, maybe it's, yep, okay, it's just IntelliSense. On detach, I don't think we need to do anything in on detach. GLM value pointer and all that stuff comes from here. So I'll just grab these two includes just in case. We probably only need type pointer, not matrix transform, but I'll keep matrix transform around just in case. Inside render, what I want to do is, if we scroll down, I want to set the clear color and clear it. We'll have to do a begin scene. I'll just grab all of this, kind of like what I did with onattach, because it's just easier than jumping between the files all the time. So yeah, this stuff doesn't need to exist. For the flat color shader, we definitely need to still upload that uniform float 4, which is uColor, which is our square color. So what I'll need to do for that is probably include the OpenGL shader, which, yes, we will fix, don't worry. This won't be a thing once we finish the 2D renderer. We won't have to do this silly dynamic cast thing. M square color is actually a vec4 now. I just thought I'd do something a little bit different, so it's not completely boring. Color edit 4. And then we've got M square color, which is good. Upload uniform float for as well, which is good. We don't need to do anything here at all. Really all I want to do is bind the flat color shader. M flat color shader, bind, and then what we'll do is we'll submit, I guess, the flat color shader. Well, if that's happening actually, and we've bound it here, so this doesn't need to exist. And I think submit binds it as well. Yeah, it does. So really we don't need this, but we do need to bind it here just because we do need that U color uniform to be uploaded there. Okay, and then what do we need to do? So we submit it with a particular transformation matrix. The camera controller hopefully has the actual camera stuff in it. I think that's all we need to do. So this is looking pretty, as you can see, it's a lot cleaner than what we had inside Sandbox app. We haven't tested it yet to make sure it works, but hopefully it will. I don't think I'm missing anything. Sandbox app now loads. Well, let's fix up all the compiler errors we now have due to the API changes that I made. Sandbox 2D needs, I think it needs a title, like a name for the layer. We'll still maintain this stuff. So we'll still have a destructor. Yes, I can just set that equal to default. And then Sandbox 2D, sorry. And then for the constructor, if we shoot up to the top, we will just do layer and then Sandbox 2D. Okay, cool. So that looks pretty good to me. The other issue we have is that orthographic camera controller, of course, needs to be set up. So we'll just grab M camera controller here and paste that in here. And I think we should be good to go. So with our layer, our sandbox layer being the one that's being pushed, let's hit F5 and we will see what happens. Okay, so now we're getting an error saying that main is already defined in Sandbox 2D. Now, this could be a tricky error, but it's actually a result of something that we've done earlier that we shouldn't have done. If you take a look at the Hazel header, so if I just open that here by go to document, you'll see that we're including this entry point into every single CPP file essentially that includes hazel.h. And since Sandbox 2D is in fact including hazel.h, we are now getting that entry point, which is, if we take a look at what entry point actually is, this entry point is an actual main function and that's being included everywhere. Now the solution here is obviously not to have this here, so this entry point should never be included. We'll get this out of here. I don't know also why syntax highlighting isn't working, just because I guess half of Visual Studio crashed through me making this episode, because clearly this code is too complicated. I'm quite surprised, to be honest, that Visual Studio can't handle this. Anyway, that aside, we basically need to include the entry point only in the place where the entry point is actually needed. And I guess just to match the angular brackets, that's what I'll do here as well. So entry point included in only the place that it needs to be included in, which is here. And everything else, of course, just includes Hazel, which does not include the entry point. Let's hit F5 again, and hopefully this will now compile and run successfully. Okay, and as you can see, we have a blue square. If I scroll in and out, that stuff works as well. WASD seems to work, and if I try and change my square color, that also works, which is pretty cool. And we have this kind of alpha control, which you can see we can also use to kind of fade the square out because we made it a 4-component color. So that is our layer complete. You guys can see that it is a really kind of clean layer that we've created here that just has everything to render that little square there, as well as all the camera movement and stuff like that. Over the next few episodes, we're going to be stripping this stuff out and converting it into just render a 2D essentially, which is the beginning of our 2D rendering in Hazel. Hope you guys enjoyed this video. If you did, you can hit that like button. You can also help support the series by going to patreon.com/thecherno, as I mentioned earlier in this video. Let me know what you guys think about the future of Hazel in general, as I talked about earlier, and I will see you guys in the next episode. Goodbye.